ASB has spent $300 for a dance. The tickets cost $5. Everyone has an ASB card. Write a function for the profit in terms of the number sold. Note, we could deal with the fact that there's two different prices, but it's just easier to deal with this. We're going to sketch a graph, mark the break-even point. So again, just like the last one, what we want to do is see how is this changing? How is this changing? What we want to do is write a function for the profit. How do we compute profit? Well, profit's going to be our revenue minus our cost. So if we're not sure on how to approach, we can start dealing with specific numbers. What if, and we said something, what's changing? Number of people and our profit. What if we had 10 people? How much money would we have coming in? How much revenue would we have? Well, the tickets cost $5 each, so we would have 5 times 10. And what's our cost for it? Well, it's a fixed cost of $300, so we will subtract 300. Based on our last work, this is probably enough to show what to do. We could plug in 100 and see what would happen there. If we use t for the number of tickets, we could say 5t minus 300 will equal p of t. So let's define those variables. Let t equal the number of tickets, and in this case it'd be number of tickets sold, and then p of t would be our profit. Now that's it for there. We've done this, and it even told us in the problem number of tickets sold is it can be one of our variables, and then the profit's the other one. Let's sketch this graph. Now in this case, what would the domain be? Domain again is going to be, doesn't ask us, but let's write this down anyways. T has to be whole numbers. What about our profit? P of t, again we're not using formal notation, we're just talking about the ideas here. P of t, if no one showed up and paid for a ticket, then they would lose $300. So that would be the minimum. It'd be greater than or equal to negative 300, because they would lose the $300. So let's set up we need to sketch this. We'll do something like go by 300s. So we have a y-intercept, or in this case a p-intercept, and we have t, and we can say p of t in this case, and it has a positive slope. What is this point? This is our break-even point. How do we find that? What's true about that? What is our profit? At that point, p of t equals 0. This is also known, what we'll talk about later on, as the zero of a function. So take 0 and plug it into 5t minus 300. 300 equals 5t, so t equals 60. So as long as 60 people show up, they will break even. If more than 60, then they start making their profit. And that's it for that one. Let's look at the last couple of them. This is just a review of some function notation. We have f of x. Remember, this is one thing. This is like your y values. This is saying for whatever value we have in here, this is going to be put in the x spot. Now it says f of 3, so f of 3 will equal 2 times 3 plus 1, so 6 plus 1, 7. F of 5 minus f of 4. This is two different questions, and then we're going to subtract them. So just to show them clearly, I'm going to separate them. We go back to what f of x is. So 2 times 5 plus 1 minus the quantity of 2 times 4 plus 1. So we have 11 minus 9, 2. The last one's a little bit different. You've dealt with those before though. The first thing we're going to do is find the inside part. So we'll just leave the f of alone out there, and f of 1 would be 2 times 1 plus 1, which will be f of 3. And now we find f of 3, and we did that. That's 2 times 3 plus 1, or 7.